What's going on, Math 10C? So here we're going to be looking at chapter 2.6. This is the final section of trig, and this is just looking at more complicated questions, okay? Now, to understand how to solve complicated questions, it does take a lot of practice, but there's also a few things to keep in mind. So how do I solve difficult questions? First thing is, it's a skill to organize your thoughts and understanding of a question, okay? You have to be organized in writing out your solutions. If you are organized, your brain's organized. An organized brain is one that understands what the question's asking. In order to do that, sometimes it's good to take a problem and put it in your own words. That means use symbols and diagrams, even if the information is obvious. Obvious information muddled in one big sentence becomes confusing information. So write it out in a more concise way. Your brain analyzes questions better if you put pen to paper. So that's even when you're feeling maybe anxious or nervous, you might write stuff down. That's because your brain is analytical, okay? It looks at things and wants to write it down and organize. That's just the human nature. And you always want to try and visualize questions, okay? Even if it's a simple triangle, draw that triangle. So let's look at example 1 here. In the diagram below, where kg equals 8 centimeters, gh equals 2.5 centimeters, and hj equals 5.3 centimeters, determine each measure. Okay, so let's first start off by writing out all of these things, okay? We have k to g equaling 8 centimeters. So this is 8 centimeters. We have g to h, which is 2.5. So here's 2.5. And lastly, we have h to j. H to j is 5.3 centimeters. Now, all this question says is determine each measure. So that literally means find every single measurement you can. Okay, so here, we need to find the lengths. So lengths we need to find. So what are the lengths we need to find? Well, the lengths we need to find are k to h. So k to h is a question mark. And we also need to find k to j. So you can see I'm already writing out things I need to find here. Now, before we move ahead, why don't we just start solving for these things? Okay. So what I'm going to do here is I'm going to say, okay, I need to find k to h. So what are the things I can use to find k to h? Well, something I noticed is there's a triangle here, GKH, and this is a right triangle. So let's draw that triangle out to the best of our ability. So this is KGH. Recognize I've just taken this triangle out and drawn it here. There is a 90-degree angle here, and we know two sides to this thing. Okay, so at this point, looking at this question here, I'm trying to find k to h. Well, remember, anytime you're faced with a right angle triangle, determine where your hypotenuse is. The hypotenuse is the opposite side of the 90-degree angle, so that's k to h. So this is my hypotenuse. Now recognize you have two sides and you're looking for one. That should be an alarm saying let's use Pythagoras. Now remember, in Pythagoras, it's just important that this c is hypotenuse. So if I write this out, my hypotenuse is the thing I'm trying to find, kh squared. I can put a as either 8 or 2.5, and then the other one, whatever remains. So let's just make this 8 squared plus 2.5 squared. And now we're solving for k to h. So remember where our squared button is. Our squared button is found right here, so this will be 8 squared plus 2.5 squared. As you can see up here, we've got 8 squared plus 2.5 squared. That gives us 70.25 equals kh squared. Now remember, we are trying to solve for kh, so we need to square root both sides. How do I get my square root? Remember, the square root is on the yellow where x squared is, so press the yellow button second and press your square root and plug in the whole number, 70.25. So that means k to h is 8.3815 centimeters. Okay. Now it doesn't tell us what to round it to, so let's just round it to 1 decimal place. So there's one solution here, and we can actually write that. This will be 8.4 centimeters. Okay, so we have found k to h. How about looking at this and trying to ask yourself, how can I find k to j? Okay, well, something to understand is this here, KHJ triangle, is not a right triangle. So we can't apply Pythagoras or any of our trig ratios. So this KHJ is actually quite a useless triangle to us. But what's a more useful triangle is K to G to J, because that forms a big right triangle. So let's draw that out. So we have K to G, right angle here, G to J, and this is K to G. So K, G, J, K, G, J. Let's write out all of our measurements. So this is 8 centimeters. Now, what is K to J? K to J is the addition of 2.5 plus 5.3. So this will be 2.5 plus 5.3. .5 plus 5.3 gives me 7.7. Let's maybe just check that. Yeah, good thing I checked. I just had a brain fart there. That is 7.8. So sometimes it's always good to just even check very simple things. Now recognize angle G is a 90-degree angle. So let's note that. So we have 90 degrees here. Okay, so again, we're trying to find K to G, or J, sorry. What is K to J in terms of this triangle? Well, it is opposite of the 90 degree, making it the hypotenuse. So again, we're going to have to use a squared plus b squared equals c squared to solve this question. Again, all that matters in Pythagoras is that you put the hypotenuse as c. So this will be k to j squared. And now a can be either 7.8 or 8. Let's put it as 7.8 squared plus, and the other one has to be 8 squared. And now we can plug these into our calculator. So here we have 7.8 squared plus 8 squared. So that gives us 124.84. And that equals k to j squared. And now I just have to square root both sides. So this will give me second square root 124.84. K to j equals 11.17, and I'm going to round it to 1 decimal place. So now we found the other side length. I can write that over here, 11.2 centimeters. Awesome. So now we found all of the side lengths. What's left? Well, what's left is the angles. So we must determine angles. Okay, so what are the angles we have to find? Well, we're going to have to find this angle here. I'm going to call this angle 1. We'll have to find angle 2. angle 3, angle 4, angle 5. Okay, so that looks like a ton of work at first. But understand, it's not super hard if you know just simple geometry that you've learned before. Okay, so let's focus on finding angle 1. Okay, so find angle 1. So looking at angle 1, it's in our triangle KHG. Okay, so over here. So I can draw this triangle out one more time here. So this is K to G to H. Remember, this is 8 centimeters, 2.5, and this is 8.4. Okay, how am I going to find this angle? Well, I have lots of options. Okay, I have all the side lengths, and as soon as you have at least 2 side lengths, you can always find an angle. So in this case, what I'm going to do is I'm going to ask myself which ratio, sine, cos, or tan, relates what I have to what I'm trying to find. So in terms of angle 1, looking at angle 1 here, this is your hypotenuse, okay, because it's opposite of your 90 degrees. In the perspective of angle 1, 8 centimeters is opposite. Okay, so this is opposite, making 2.5 adjacent. What relates opposite and adjacent? Well, that would be tan. So tan angle equals opposite over adjacent. In the perspective of tan angle 1, the opposite side length is 8. The adjacent side length is 2.5. And now, to solve for angle 1, you take the inverse of tan and plug in that ratio. Okay, so let's do that. So I'm going to do, remember where inverse tan is. Inverse tan is in the yellow. Okay, make sure your calculator is on degree mode. So we're going to press second, tan inverse, and plug in 8 over 25. Or sorry, 8 over 2.5. And that's going to give me 72.64 degrees. Okay, and I'm going to actually just round this to 72.6 degrees. 72.6 degrees. So that's angle 1 right there. So we've already found angle 1. Now, we can easily find angle 2. Okay, angle 2 is right here. Why can we easily find angle 2? Well, remember, all the angles in a triangle add up to 180 degrees. So my next step here is going to be find angle 2. The way I'm going to do that is because I know angle G plus angle 2 plus angle 1 equals 180 degrees. That's true for every triangle. We talked about that last video. So angle G here is 90 degrees. So this will be 90 degrees plus, we're trying to solve for angle 2, plus what we just found, angle 1 being 72.6. That equals 180 degrees. So remember, when we want to reuse an equation, when we want to reuse a value, you usually don't want to use the rounded value. You want to use this whole value. So to add 90 to this entire value, we're going to do 90 plus, and we're going to press second, answer. And remember, answer is what you found last in your calculator. So that gives us angle 2 plus 162 degrees. That equals 180. And then we're going to subtract this by both sides to solve for angle 2. Now recognize again, we want to use the whole value here. So I'm going to plug in 180 minus, I'm going to press second, and answer. So that gives me my angle 2 of 17.4 degrees. So now we have found this guy, which is 72.6. And we have also found this guy, which is 17.4 degrees. Okay, so how can we solve for other things here? Looking at this, if I know some simple geometry, I can actually find angle 5. Now this is some geometry you learned in grade 9. This is a perfectly straight line. A perfectly straight line has an angle of 180 degrees. So recognize angle 1 plus angle 5 also equals 180 degrees. So let's do find angle 5. So that's true for any straight line. A straight line always makes an angle of 180 degrees, which makes sense. So you have angle 1 plus angle 5 equaling 180 degrees. We found angle 1, right, to be 72.6 plus angle 5 equals 180. Now I subtract this guy, and I subtract 72.6, and I'm going to get angle 5 being... Now, your calculator might be kind of new, and remember, we want to use this whole answer, not the rounded answer. So I'm going to do 180, and I'm actually going to go up here. Okay, first I'm going to press subtract, and I'm going to go up to there by pressing the arrow button. Okay, your calculator may or may not be able to do this, but it's good to try. And I'm going to press enter, and it should pop that answer up right there. So that gives me 107.35 degrees. So that means angle 5 equals 107.4 degrees. Okay, so there is some trig review right there for you. So now we have angle 5. Angle 5 equals 107.4 degrees. Now, the last things we need to find is angle 4 and angle 3. Angle 3 is a little bit of an awkward angle because remember, we can't use trig ratios on this triangle, k to h to j, because it is not 90 degrees. But we can find angle 4 because it is a part of a right triangle, which is k to g to j. Okay, so let's find angle 4. So I'm actually going to use this triangle over here to find angle 4 right here, which is angle j. So right here. So this is angle 4. So let's go find angle 4. How can I find angle 4? Well, what am I given? I have this side length, and I even have k to j because I solved for it. Determine where your hypotenuse is. Your hypotenuse is found here. And what are these side lengths in relation to this angle? Well, in relation to angle 4, this is the opposite side length, and this has to be adjacent because remember, hypotenuse cannot be adjacent. So let's use tan. Tan relates the opposite and adjacent to an angle. So tan angle equals opposite over adjacent. In perspective of angle 4, its opposite is 8, and its adjacent is 7.8. And remember, we're trying to solve for this angle, so we are going to take the inverse of the ratio. So angle 4 equals remember, second tan to get tan inverse, 8 over 7.8. Oh, I didn't press second. So I see that's a really ugly number. I should really check back. I never pressed second properly. So second, tan. Now I have my inverse tan. 8 over 7.8. So that gives me 45.72 degrees. So I now have angle 4. And now, hopefully you can see, to find angle 3 won't be that hard because we have one angle in a triangle and another angle in a triangle. That rule of 180 degrees equals the sum of all angles does not just have to be a 90 degree. It relates to any triangle. So finally, find angle 3. Okay, so we're going to find angle 3 now. That's kind of a weird way to section it off. There we go. Find angle 3. Well, here we have angle J, we have angle G, and we're trying to find angle K. Remember, we're talking about this triangle here. So we're trying to find angle 3. So this is angle 3 here. So recognize angle 3 plus angle G plus angle 4, which is angle J, equals 180 degrees because any triangle's angles add up. So that will be 90 degrees plus 45.72 degrees plus angle 3 equals 180 degrees. And then from there, we can solve this. So let's add 90 plus 45.72. Remember, we want to use the full answer. So I'm going to press second answer plus 90. So that means angle 3 plus 135.72 degrees equals 180. And then I can subtract both sides. Oops, sorry about that. Okay, so we are going to end up getting 180 minus second answer. So that gives me 44.3 degrees. And now we have found absolutely everything we can about this question. So really important to understand that straight lines, their angle is 180 degrees. That's how we solve for angle 5. Always try and determine where your right triangles are. We didn't really focus on K to H to J because that's not a right angle, okay? So you can't apply any of the trig ratios or Pythagoras. So remember, pause the video, rewatch it, find parts that confused you, and make sure you come in and ask lots of questions. Okay, let's look at this question, and then we can end her off there. So a student uses a clinometer to measure the angle of elevation of a sign that marks the point on a tower that is 50 meters above the ground. The angle of elevation is 37 degrees, and a student holds a clinometer 1.5 meters above the ground. She then measures the angle of elevation of the top of the tower as 49 degrees. Determine the height of the tower to the nearest tenth. Determine the height of the tower to the nearest tenth of a meter. The diagram is not drawn to scale. Okay, so we have a few things here. We want to know this entire height. So essentially, what we're actually trying to solve is what this height is here. Because if we can solve for this height, we can add it to 50 and get the full height of this tower. Okay, now recognize we have two right triangles again. So we have two right triangles. So what I'm going to do is I'm going to list all the intersection points, okay, where lines meet, and I'm going to note those. So how I'm going to do that is I'm going to use my lettering system. So in this case, I'm going to label this A, B, C, D. Now that's going to help me in solving for this question. Now, why is this going to help me solving this question? it's going to help me solve this question because now I can label these triangles properly. So here, I have two triangles. I have a right triangle. I have one right triangle, which is A to B to D, or sorry, A to B, to D. So right here, A to B to D. So there's one right triangle. And I have another right triangle, which is A to B to C, which is a little smaller. Still a right triangle, so this is A to B to C. Now, recognize I'm trying to find the measurements from D to C. Okay? The reason I'm trying to find the measurements from D to C is because I'm going to add it to 50. Now, how am I going to do that? Well, looking at this question, I could find the measurement of D to B, okay? And I could also find the measurement of C to B. And then I could subtract those two things to find D to C. So let's say that again. I know that if I find D to B, I can subtract that from C to B, and that's going to give me D to C. Okay? So again, D to B minus C to B is going to give me D to C. This is kind of my end goal right now. Okay? So let's focus on finding D to B. So let's maybe move this guy over. Find D to B. Okay, so that's right here. Well, what do we know about this triangle? Well, we know in triangle ADB, okay, that this has an angle of 49. What else do we know? We know that's all we really know about this triangle. We can try and find A to B here. Now recognize A to B pops up in both triangles. Okay, so is there a way to find A to B over here? Well, let's check. So triangle A to B, triangle ACB here, actually we can find that because we can just figure out what C to B is. We have an angle, therefore we can solve for a length. So this is 37 degrees. C to B is going to be 50 minus 1.5. So this is 50 minus 1.5. So that's going to give me 48.5 meters. Okay. And now hopefully you can see, well, I have a angle, I have a length, therefore I can solve for another length. How do these all these things relate? Well, first off, find your hypotenuse. This is the hypotenuse. In terms of this angle, this is opposite, making this have to be adjacent. What relates opposite and adjacent? That's tan. So tan angle equals opposite over adjacent. Now let's plug in. If I'm talking about tan 37, my opposite length to 37 is 48.5. And my adjacent length is what I'm trying to find, A to B. And then from there, I can solve for A to B. So I'm going to multiply A to B over 1 by both sides, and that's going to cancel out my A to B. So I get AB multiplying tan 37 equaling 48.5. And then from there, I need to divide tan 37 away. and I will get A to B equaling 48.5 divided by tan 37. So here, I will get 48.5 dividing tan 37. So that gives me 64.3616 meters. Okay. Now, I have A to B. Remember, A to B also shows up in my other triangle that I'm dealing with. So I have this length, 64.3616 meters. Now I can officially find D to B. How do I find that? Well, remember, I have this angle. Here is my hypotenuse because it's opposite of that 90 degrees. D to B is the opposite, making this guy the adjacent. What relates opposite and adjacent? Well, we just said that's tan. Tan equals opposite over adjacent. So now we can plug in our tan 49. Our opposite is our D to B, and our adjacent is 64.3616. And from there, I can solve for D to B. I'm going to multiply both sides by 3.616 over 1 to cancel out my 64. Okay, I'll multiply this side by that as well, because what you do to one side, you must do to the other. And then I'm going to get $64.3616 multiplying tan 49, and that's going to equal D to B. So let's plug that in there. So remember, second answer gives you the last solution you got. So I'm going to press second ans, and I'm going to multiply tan 49. And that gives me D to B, which is 74.0396 meters. Okay, so let's remind ourselves what we're trying to do. We're trying to find the length of this. We have just found D to B. Why did we find that? We found D to B because now we can find D to C here, and then we can add it. So D to B minus C to B is going to give me this. So here, D to B we just solved for is 74.0396, and we're going to subtract C to B. C to B we figured out is 48.5. So minus 48.5, and that's going to get us, so remember, I want this last answer, so second ants minus 48.5. So that gives me, I should probably move things over here. Just fix that quickly. So that gives me 74.036 minus 48.5 equals 25.53 meters. Okay, so I'm not quite done. I have found D to C now. Now to figure out the total height of this, I simply have to take D to C and add it to this 50 meters. So height equals 50 meters plus 25.5 meters. So 50 plus, and I want to use that whole answer, so second answer. And that gives me 75.539 meters. And what does this want to round it to? It wants us rounded to the nearest tenth of a meter. So that will be 75.5 meters. Okay. So this is definitely a hard question. Okay. Try it out on your own. Rewatch the video as many times as you need to. Come in and ask questions if you're confused. Okay? Solving for these takes practice. So make sure you go check your understanding with 2.7. And anything that's confusing you, please come ask. Okay? So I definitely realized I accidentally put 2.6 here. This should say